guys, welcome back to a new episode of MrLopezClasses.com. In this episode, I am going to explain the pedestals, the AC power coming into the boat from the pedestals. What happened with the pedestals? Why is important know how is the wiring, how is the configuration in a pedestal. In some cases, the problem is not in the boat. Normally, when the captains have a problem, have an electrical problem, they call immediately to the manager of the marina asking about the power coming from the marina. And they said, oh, the problem is the power coming from the marina. If you are the engineer responsible for the electricity in the marina, you need to be in charge of the power on the pedestals. And you need to be in charge on the power on the transformers in the marina. Right now, I am going to explain what happened with the pedestal, what is the procedure to fix the problems on pedestals, and what is the procedure to solve those problems. Okay, the pedestals, like this, are basically a unit that receives the power from the transformer on the dock. The transformer on the dock receives the power from the transformer at the main entrance of the marina on the street. The transformer on the street passes the current to the transformer on the dock, and the transformer on the dock sends power for each pedestal. In each pedestal, you found 3 or 4 bus bars. For example, this particular bus bars is for three-phase outlet. Hotline 1, hotline 2, hotline 3, neutral and ground. And at the bottom you have the bus bar for the phases and the neutral. This is the input, that's the power coming in from the transformer. Big cable. For example, this is the cable number 2 with the power coming from the transformer. Cable number 2 with the 100 amps coming in. And this is the output. The output is number 6 with 50 amps for the outlet. The big one, number 2 with 100 amps coming in, and the output, number 6 with 50 amps for the outlet. I'm going to explain right now that situation. We have the main bar. The power from the output enters into the breakers. And from the breakers goes into the outlet. I have an schematic to explain to you the procedure to check the pedestals. In the majority of the pedestals in the marinas, you found it in the bottom, the faucet of water. This is, in my opinion, a bad design. This is a wrong design. The enemy of the electricity is the water. Why the engineers, the smart engineers, design the faucet of water separated with the electricity 2 inches, 3 inches. This is not good. In my experience for years and years working in marinas, the majority of the problems with the pedestals is when you have a leak of water on the faucet, the water splash and produce shortcuts. I don't like this design. If you have the chance to eliminate the water on the pedestals in your marina, eliminate the source of water. Connect the source of water in other separate equipment, not on the pedestal. The pedestal is for electricity. You have high current, high tension. Never put the water close to the electricity. Bad design, wrong design. Okay, this is the schematic. This is the schematic that I have of the pedestal. This is the short power cable, and this is the pedestal. Those are the 3 lines. In this particular case, I am going to do the example with double phase. I am going to check outlets like this with a hotline, neutral, and the ground on the side. Double phase. Okay, in this particular example, I have a phase number 1, the black one, phase number 2, the red one, coming from the transformer at the beginning of the pedestal. This is the power, 240 volts, 60 hertz, 100 amps. That power enter in the bus bars. Bus bars for hotline number 1, bus bar for hotline number 2, bus bar for neutral, and other bus bar for ground. Okay, from the bus bars, the bus bar receive the big cable number 2 with 100 amps. And the output cables going into the breakers are smaller cables, number 6 and 50 amps. Hotline number 1, hotline number 2, and neutral. And this is the power coming in, neutral coming in, and ground coming in. From the output, with the wire number 6, go to the phase number 1, the red one from the red one, and the blue one from the blue one. And those are the outputs. The output goes to phase 1, phase 2, and neutral. Those cables are number 6 for 50 amps. And the cables coming in are number 2 with 100 amps. Remember, when you have one hotline here with 120 volts, 60 amps, and you put together other phase different, 120, 60 amps, right now you have, in this point, 120, 60, and 60 with 120 amps. You added the amps, the voltage is the same. You can put 4 cables, 120, 120, and 120. The voltage in that point is 120. Oh, the amps is this plus this plus this plus this. All right. This is the breaker to control this outlet, and this is the breaker to control the second outlet. Each outlet will be for 50 amps. Each outlet will be for 50 amps. And this is the outlet that at the end of the day will be connected with the outlet at the entrance of the boat. The short power enters here and goes into the boat. This short power cable is for 50 amps, and this is for 50 amps. This is the typical connection of a pedestal, and this is the configuration of the wiring. Suppose that the captain said that in my boat right now I have one phase, good, 120, and the other phase is nothing, 0 amps, when the boat is connected in short power. When I power the boat with generator, both phases are okay. What do you think about that situation? When the boat is connected with generator, both phases on the AC panel of the boat have 120 and 120, no problem. When you switch the switch selector to short power, right now one phase is 120 and the other one is 0. What is the problem? The problem is in your boat? Probably the problem is not in your boat. Probably the problem is on the pedestal. One phase is good and the other one is not good. What is the procedure to do that troubleshoot? The first step is go into the pedestal and verify if the power coming in is okay, and if the power coming out into the breakers is good. This is the procedure. That's the pedestal. You open the windows of the pedestals and you verify the bus bars, the big bus bars. With the voltmeter in volts AC, you select volts AC, the first function, you check the voltage in between the neutral bus bar and this bus bar. The voltage should be 120 volts. When you check the voltage in between the neutral and the other bus bar, the voltage should be 120. Okay, let me check. 120 and 0. I don't have power in this phase. I don't have power coming from the transformer in this bus bar, in the hotline number 1. What is the next step? Go at the beginning of the dock, open the cabinet where the transformer is located, and verify what is the breaker designated for this pedestal. This is the pedestal 17. I check on the cabinet the breaker for pedestal 17. I turn off the breaker and I verify the input power and the output power. Okay, you need authorization from the marina normally to open the cabinet where the transformer is located and the main breakers are located. In the majority of the cases, you need to call the manager of the marina in order to do that procedure. Okay, you verify over there and you found it that the breaker for pedestal 17 on the dock, at the input of the dock on the transformer is broken. That the solution is replace that breaker. This is a problem related with the manager of the marina. You only explain to him that the breaker is damaged and the marina replace the breaker. Right now, you replace the breaker, you verify that you have power here, 120 between neutral and hot, 120 between neutral and hot, and now in between hot and hot, 240. Okay, the input power coming from the transformer is okay. Let me check my breakers. My breakers, I have a 120, 120, 240, 120, 120, 240. Okay, both breakers are okay, and right now the outlets are okay. How can I check the outlets? Exactly the same. I introduce between hot and neutral. The reading should be 120. In between hot and the other neutral, 120. In between both hot lines, 240. If in this outlet I only have power only in one, the other one nothing, but the breaker is okay, you need to replace the outlet. That's the procedure. You need to go step by step. You start on the transformer at the beginning of the dock. After that, you check the bus bars. After that, you check the breaker. And after that, you check the outlet. This is the procedure to isolate the problem. The problem is on the outlet, the problem is on the breaker, or the problem is on the bus bars. Other common problem with pedestals is about the hour meter. The hour meter is used for the manager of the marina in order to verify how much is the consumption in amps of the boat in that pedestal. All right. The procedure to verify the consumption in amps of each phase in the pedestal is by means of donuts. The same donut that we use to connect the ammeter. You remember in the chapter 12, I think so, the episode related with the connection of the gauge, voltmeter and ammeter. Okay, the procedure to connect the ammeter in AC power is with the donuts. The donut is a magnetic donut. They have the positive and the negative over there. When the current pass here, the cable pass in the middle of the donut, the AC signal, positive and negative, touch the magnet, and the magnets check the amount of cycles passing in 1 second. According with the amount of cycles passing in 1 second through this point, that signal enters into the voltage controller, and the controller is a small computer that calculates the amount of cycles passing for that point per second, and the gauge, the hour meter, registers the amount of amps per second and convert into kilowatts. And when you call the manager of the marina in order to pay the bill because you want to leave the marina, they prepare the invoice for you, and they only register how many kilowatts is the consumption during the time that the boat was docked over there, and the bill is according with this amount. I am going to repeat again. Okay, the hour meter in the marinas is exactly the same the hour meter that you have in your home. That hour meter registers kilowatts per hour. Okay, but the kilowatts are coming for the amount of amps per hour. Remember, power in kilowatts is equal to the voltage times the intensity. Okay, in this particular case, the voltage is 240, and the intensity is the amount of amps passing per second through the donut. Okay, what is the procedure to calculate the amount of amps? Okay, I am going to calculate the amount of cycles. All right, how can I calculate that? I pass the cable here through the donut, and the donut registers the amount of cycles here into the voltage controller, and the voltage controller convert into kilowatts per hour. All right, if the manager of the marina complains that in this pedestal only the hour meter for phase number 1 is working and the hour meter for phase number 2 is not working, you need to verify what is the problem. The problem is on the donut, or the problem is the voltage controller, or the problem is the hour meter. It's very simple. You need to verify if the donut is sending a signal here into the voltage controller. And normally, the majority of the voltage controller, they have a LED, red light, that is constant, is solid when the voltage controller is working. The recommendation, when you have problems with the hour meter, is replace at the same time the donut and the voltage controller, because those elements are designed to work together, the donut and the voltage controller. The recommendation is try to keep in your marina a lot of voltage controllers and donuts, because they should be replaced, both of them at the same time. If you have suspicion that one phase, the reading in one phase is erratic, replace both of them. Don't try to fix it, because it's impossible. Open the donut and repair the donut, or open the control box, because it's an integrated circuit board. It's very simple. It's the gauge, the voltage controller, and the donut. You have one donut in each phase. You have one donut for phase number 1, and you have another donut for phase number 2. The other donut enter here. If you have other donut here, the other donut is here. The cable from the other donut enter here, and both of them register in the hour meter. In other words, each voltage controller receives the signal from both donuts if the pedestal is double phase, or from 3 donuts if the pedestal is 3 phases. It's donuts, voltage controller, and the gauge. That's very simple. This is exactly the procedure to check pedestals. That's the procedure to check if the breaker is in good condition or not, the procedure to verify if the outlet is good or not, the procedure to verify if the power coming in from the transformer is good or not, or the procedure to verify if the problem is the breaker on the cabinet where the transformer is located. I hope that you enjoyed this episode. Thank you.